Hello everyone, this is Ashani from Cheenta.com. Today I will discuss a very interesting problem from UKMT. UKMT is a math Olympiad in United Kingdom. This problem at the first glance appears to be wrong, but then if you look carefully, you will see something called a ghost constant. Ghost constants are everywhere in Math Olympiad, algebra, number theory, geometry, and so on. So it's a very important concept. Today in this video, we will learn that. At the end of this video, I'll also give you a challenge problem. Please look out for that. If you are interested in Math Olympiad courses, you are in the right place. Cheenta has some outstanding programs on Math Olympiads. Some of them are live classes. Some of them are self-paced courses. You can check the link in the description for more detail. All right. So let me tell you what the problem says. There are two unshaded circles. So this is the unshaded circle 1 and this is the unshaded circle 2. And they touch each other while they touch a bigger circle. And there is a chord of the bigger circle, PQ, which is tangent to these two small circles. And the only information that is given is that PQ is 6 units. PQ is 6 units. That's the only information that is given. We do not know the radius of the smaller circles. We do not know the radius of the larger circle. None of the radii are actually given. We want to find out the area of the shaded region, this area. So that's why this problem appears a little bit tricky. You have no information whatsoever about the areas of the 3 circles involved. And a chord of 6 units, that can be in any circle, right? You can draw any circle, like sufficiently large circle, and you can draw a small enough chord here. That's totally fine. It's fine. You can get a 6 centimeter chord. So how do we find out the area of the shaded region? That's the question. So to do that, we will be using some concepts. You know already that I am a very big fan of problem to concept strategy. In this strategy, you start with a problem, a really nice problem, and then you think about the underlying concepts that makes the learning motivated. In fact, this is a strategy we use in the Math Olympiad courses in Cheenta. Always start with the problem. Okay. So these are the 3 concepts. Power of a point, ghost constant, I talked about this at the beginning, and the tangent center line. The tangent center line is a very important concept. I talked about this in just the previous video. So I'll talk about it today as well. Let's quickly see how we can talk about each of them. So concept 1, it's power of a point. Power of a point. So if you have a circle, suppose a point P is outside the circle, then the power of P with respect to the circle is the square of the tangent, is PT square, the square of the value of the tangent. Okay, and it's also equal to PA times PB. If you draw any secant starting from the point A, it's also equal to PA times PB. You can draw some other secant as well, like this. This is x and this is y. So that's also equal to px times py. So it's true for any secant. And why is this true? Well, it comes from similarity of triangles and tangent chord theorem. That's how you prove this. It's very important to prove it. Our self-paced program on Math Olympiad, also the live classroom program, we discuss these theorems in more detail. In this video, we will not. You just need this particular result. In fact, what happens if P is inside the circle? That's what we need in this particular problem. So if P is inside the circle, suppose we have something like this. This is AB. This is XY. Of course, you cannot draw a tangent. Then PA times PB is the power of the point P, which is also equal to PX times PY. So for the point inside the circle, you have to again use similarity of triangles. In the comment section, can you tell me how to prove this? So very simple and standard proof. I would love to see if someone is able to solve it. Okay. So this is and you can also draw another one. I mean, doesn't really matter in which direction you draw it. Maybe RS. Then this is PR times PS. Right? So all of these numbers, they are known as power of P. This is a very, very important constant and invariant of the point P with respect to the circle. In mathematics, invariants are very, very powerful concepts. You change a ton of stuff, something that does not change. You change the chords passing through P. The value of PA times PB does not change. It's almost philosophical in nature, how it works out, okay? All right. So, always look out for invariant quantities. Now, coming back to this power of the point P, we have this tool at our hand, and then we have the ghost constant. So, I'll talk about that in a moment. But let's talk about the tangent center line quickly. So, let's say you have two circles. This is concept 3, set 3. This is tangent center line. So suppose you have two circles which are tangent to each other at a particular point P. Okay. Let's draw the centers of the two circles. This is O1 and this is O2. It turns out that all of these lines will be on the same straight line and they will be perpendicular to the tangent line through T. And this should be obvious actually, because there is a very fundamental theorem that radius is perpendicular to the tangent. So O2T is perpendicular to the tangent. But it is also tangent to the larger circle. So O1T is also perpendicular to the tangent. O1T is perpendicular to a tangent. O2T is perpendicular to the tangent at the same point T. That can only happen if they are on the same straight line. Because given a line, given a point, you can draw only one perpendicular. Okay? So that must be the same straight line. So this is center point of tangency. Tangent center line. That's what I call it. It's very important that all these 3 points are on the same straight line. We will be using it in this particular problem. Okay, let's start. The final concept was the ghost constant. And while we solve the problem, you will see how it unfolds. So let me quickly take the picture one more time. And let's draw this carefully. Let's make this a little bit bigger. Okay. Here we go. Okay. So now, first thing you notice is that let's take the point here, the point of tangency here as R, and this one as S, this one as T, we have three centers of the circle. The first center is O1. The second center is O2, which is the center of this circle. This is O2. And finally, we have O3, which is the center of the large circle, the outside circle. Okay? All right. So, let's suppose this is small r. This is, okay, maybe I just use a different letter. Let's say this is X. This is X. Okay? Actually, it would be convenient to use small r because r is for radius. So, I call this point X. Let's call this point X. All right. So, the length of the small radius is small r. This is small r. So, this is also small r. So, this total thing is 2r. Now, we have this radius, which is capital R. So, this is also capital R. This is the radius of this particular circle. And notice that all of these points are on the same straight line. Which points? This point of tangency, this center, this point of tangency, this center, and this center, and this point of tangency. All of them are on the same straight line. Why are they on the same straight line? Well, this is a challenge that I give you. Use the tangent center line argument in the comment section and tell me why are all of these points on the same straight line. I'm sure you can do it. Give it a try. Okay? In fact, this is the diameter of the bigger circle. If it's a diameter, what is the length of the diameter? Diameter of big circle. Diameter of big circle is 2 times small r plus 2 times big R. This is 2 times small r, 2 times big R. Right? Okay. So far so good. So what is the power of the point X? Okay. So the power of the point X is power of X. Power of X is Px times Qx. Px times Qx. It's also equal to Sx times Tx. Sx times Tx. Okay, so what is Px times Qx? PQ is 6. PQ is 6. And this is perpendicular to the line PQ. Why? Because this is the tangent, this is the line through the center. From the center O2, this is the line to the tangent at the point of tangent. So this is perpendicular. But this is also the diameter. So the diameter is perpendicular to this chord. Therefore, it hits the chord at the midpoint. Therefore, Px and Qx are both 3 and 3. 3 times 3, that's 9. This is equal to Sx, which is 2 times small r, and Tx, which is 2 times large r. Right? So what you have? You have 4 capital R small r equals to 9. That's an equation that we have here. We are almost there. So what is the radius of the big circle? It is half of the diameter, which is r plus r. This is the radius of big circle. This is the radius of the big circle. So now if we want to find out the shaded region, which is this and this, it is pi r plus r whole square, which is the area of the large circle, minus pi small r square, which is the area of the small circle, minus pi capital R square. Okay, so we also know that 4RR is 9, and we want to find out this. This is the shaded region. And we are done. Why? Because if we just open up the parentheses, 2RR minus pi r square minus pi capital R square, this is pi capital R square plus pi small r square plus 2RR times pi minus pi small r square minus pi capital R square. So if I just cancel off these things, I just need the area of the shaded region is this, 2 capital R small r pi, and we already know 4 capital R small r is 9. So 2 capital R small r is 9 by 2. Can you tell me what is the value of this quantity? It's just one line. You have to just plug in the value of 2RR. Maybe you can tell me in the comment section. So this value, r times small r, this value is the ghost constant. Ghost constant means you do not know capital R, you do not know small r, but you know the product of them, which is 9 by 4. It doesn't matter how big the circle is, or how small the smaller circle is, or how big the second most small circle is. The product of capital R and small r is a constant number, which is 9 by 4. That product is the ghost constant. You do not know that constant before starting out with this problem. Okay? Alright, I hope you enjoyed the problem. I hope you learned something. It's very important that you carefully take some time to think about how all the concepts unfolded. I'm sure you will like it. Take care. I'll see you in the next video. Bye.